Hi, everybody. We talked a lot about area yesterday, and I warned you that today we'd be working on finding the area of a circle. Here's a circle, and it is on a grid, so you can see its area tiled out like that. And there are some whole tiles you could count. There's also some weird stuff that happens because of this round edge. If I ask you to find the area of this, how would you start? How would you even estimate it or approximate it or even get close? Pause here, take some time, come up with your own theory. How might you find the area of a circle? And then pause when you're ready to move on. Well, that's what I want to teach you today. I want to teach you how to find the area of a circle. So go ahead and make this the title of your next math notebook page. And when you're ready to go, close that up and concentrate with me. So yesterday we reviewed a whole lot about area. We've learned how to find the area of polygons many times in the past. Rectangles, you can either find them by tiling or using this formula, base times height, since it just makes an array of tiles like that. Parallelograms, you can turn into rectangles by cutting one edge and moving it over, which means they have the same formula as a rectangle because you can just turn it into a rectangle. So they have that formula. Triangles have nearly the same formula, but slightly different. To find the area of this pink triangle, you would double it. And when you double it, you make a parallelogram. And we know the formula for the area of a parallelogram. The only thing you'd have to remember after you found the area of that parallelogram is to divide it by 2 or multiply it by 1/2. So you would only get the area of the triangle. So we've learned some formulas in the past. We've also learned some tactics if you don't remember the formulas in the past. And now we kind of move on today to like, well, what about this? Well, first, let me remind you something else about a circle we've done, and that is find its circumference. So a few days ago, we learned that if you found a circle's diameter, that's called a diameter, across the middle, and you know how long that was, 1, 2, 3, 4, 5, 6 units in this case, across this one, that 6-unit diameter would fit around the outside of the circle exactly the same number of times the amount of the circle. It would fit around there once, twice, 3 times, and you would have just like a little teeny bit more. We actually figured out it fits around there pi times, which we usually approximate to 3 1400 times. So we figured out that if we know the diameter, we can multiply that by pi, and that would give us the circumference. So in this case, to find the circumference of this circle, that would be the circumference is pi times 6. 6 times 3 is 18. And then 6 times the 14, I'll just say what was point. It would be like something like 18.8, somewhere around there would be the circumference if I use that formula. So we figured out there happens to be a relationship between the diameter and the circumference that it fits around that pi number of times. That's going to be helpful to us today as well. Is there anything like that we could do here? If I wanted to find the area now of this circle, obviously just counting tiles doesn't work because we get these partial ones here that are real hard to deal with, and we don't really know how they would all fit together. And so tiling's kind of out as an option for a circle. There's no obvious way to cut that up and turn it into another shape either, because all these round sides, no matter what you're going to do, you're going to end up with round edges. And so none of our previous tactics really apply. So much like circumference, there happened to be a relationship you could figure out and just know like, hey, all circles work in this way. Area works the same way. So I'm going to do, here's the center of the circle. I'm going to draw a diameter this way. I'm going to draw a diameter this way in the circle. I'm going to cut the circle into quarters. 1, 2, 3, 4. Those are fourths of the circle. Now this long line from end to end here or here, those are called diameters. What I'm going to do, a diameter is this whole line. Half of a diameter, if you just go from the circle to the edge, we call that a radius. That's going to be an important word in math too. a radius is half of a diameter. And we draw it, again, we draw it from the middle of the circle to the edge. It's called a radius. I'm going to erase this one because I've still got 4 of those already here. So what you'll notice is I've got 4 of those. There's a radius here. There's a radius here. There's a radius, I'll leave it in black there, and there's a radius here. So there's 4 different radius measurements here. Each of this could be called R. We already counted the diameter of this circle is 6. The radius is 1, 2, 3. Those will always be related in that way. It's just a half of a diameter. So what I'm going to do, I'm going to take those radius measurements and I'm going to draw a square for each fourth of the circle. I'm going to draw a square like that. I'm going to draw a square like that. I'm going to draw a square using this radius. And I'm going to draw a square using this radius. So now I've taken each fourth of the circle and I've used it to draw a square. That would be an approximate area, right? It's too high. I've got extra boxes that don't count. But one thing I can figure out quickly here is if I took this radius measurement and I drew a square out of it, so I squared it, so to speak. That means second power. That means like radius times radius, right? So in this case, 3 by 3. I've got this issue where when the radius is 3, each square has an area of 9 here, right? And I can fit that in there. 4 times is too many. But not by a lot. You'll notice I only have a little bit of extra area after I do those squares. So whatever the radius is, and this works with any circle, smaller or larger, as you'll see in the we do, is if it's close to 4 squares made out of the radius. Now, but it's less than that. It's too high. It's actually less than 4. Guess how many exact times that square made by the radius could fit in there? It's less than 4. It's more than 3. Yeah, it's that same number pi again. So I could take this 9 unit square. That 9 unit square would fit in the circle 3 and a little more times. So the formula we end up with is this. The area of a circle is its radius squared. So 3 times 3 in this case to make that square, a square made by the radius, times pi. That square, that 9 unit square would fit in that circle pi times. So in this case, I know pi squared, or 3 squared is 9. That makes that 9 unit square. That would fit in there pi times. And the exact area of that circle would be that, about 28 squares. Would fit in that. And that's about right. If you were to go back and count, you'd probably believe it. Yeah, about 28 will fit in there. So that's where that formula comes from. It's a little less than if you take a quarter of the circle and make a square of it a little less times. Once you know that formula, these are quite easy to operate from there. Sorry about that. So let's just say Antoine decides to repaint the top of this table. That is using its area to paint the flat surface of this table. The table is 37 inches across. How many square inches of paint will he need? So let's go back and now just use that formula. The area of a circle is its radius squared times pi. So first thing I need to do is find the radius. It is not given to me. You'll notice I have the diameter. I just need the radius to make those squares, so I don't have it. So the radius is half of the diameter. So 37 divided by 2 is 18.5. So that means the area of that circle is 18.5 squared. That means times itself, 18.5 times 18.5 times pi. So let's finish that out. 18.5 times 18.5 times pi, or my approximation of pi, since that's all I have on this. Looks like a little more than 1,074 square inches. So I'll say 1,074 to 1,075 square inches to paint. That is how it works. All right, open up your math notebook. Let's talk about the formula, and let's talk about an example. So go ahead and start now, if you will. I want you to know where the formula comes from. I always hate for you to just memorize and think that it's just some math teacher voodoo magic. There's definitely a way to do this. So the way this works, if you want to draw it on your drawing, is you'll notice if you make a radius square, radius times radius, and you can make 4 of those fit in there. So I would say that, if you make a square using the radius, a little less than 4 times the squares fit in the circle. And actually, it is pi of the square. That's how it works. That's what I want you to write down. I want you to know where that comes from. So our formula is the area of a circle equals pi times the radius squared. A square made out of the radius 3 and a little bit of times fits in the circle. So go ahead and pause now when you've got that and you feel like you understand it. If you're totally confused by this, just go back to my explanation on I do and watch that again, because I do want you to feel like you have some good idea of where this formula comes from. And then let's do a quick example as well. So farms often use circular fields, true story, because they can use rotating sprinklers to water them, right? They'll take these sprinklers like this and just rotate them around the circle. And that's why often, true story, farms have these round fields, because it's easiest for them to water them with machines that way and not to do it. So a new round farm is being created from a square area that has an 800 meter side length. And that's all in your picture. How many square feet of crops can be planted in it? So we'll notice here, thanks to this 800, the diameter of the circle is 800 meters, which means the radius of the circle would be half that, or 400 meters. And now we can just use that formula to figure that out. It's pi times the radius squared. So that means for me, the area of the circle is pi times the radius is 400 to the second power. That's 400 times 400, which I need to know. Could have done that in my head, actually, but I didn't. It's about 160,000 square meters, and that square made by the radius would fit in there pi times. So nice big farm. Going to have about 502,400 square meters. You can fit a lot of crops in a circle like that. So y'all, 2 big things to take away today, and I want to hope that they worked for you after you've written this down. First, I want to make sure you understand why a formula is needed to find the area of a circle. You can't just tile it and count because of those round sides. I want you to understand why that formula is pi times the radius squared. And last but not least, I want you to be able to use that formula to solve problems involving the area of circles. Just be able to find that radius and use that radius to find that area. Hope that all makes good sense to you. I tried real hard. If it does, you're all set. If not, please go give this another watch and you'll come to school all ready to do a great job tomorrow. See you there.